You're watching the second video on rates, ratios, and relations. This video will be talking about equivalent ratios. This will be something very similar to fractions that you've done in grade 6 and 7. We're really just doing the same thing with ratios. So if you remember what equivalent fractions are, so again, equivalent fractions are fractions that can be simplified into the same one. The same thing is applied in ratios. So if we look at this one, we have uh, a pie and we have two halves, right? We have one part and two parts. And of the two parts, we have one of them. So we can say in a ratio, we have 1 to 2. And in this one, we have four parts. And of the four parts, we have two of them. So we can say we have two of four parts. Here we have 8 parts in total, and we actually have 4 out of the 8 parts. Now, with these ratios, if you recall from the previous lesson, these are part to whole ratios. These are ratios that show a relationship between one part, number of pie slices you have, to the total, or the total number of pie pieces that could exist, right? So here we have one part of a total of 2 pieces, we have 2 parts of a total of 4, and 4 parts of a total of 8. And so if you are doing a part to whole ratio, you can basically treat them the same way as you would a fraction, right? 4 and 4 out of 8, right? And so if you recall from your previous years of study in math, you know that these fractions are equivalent. These fractions are the same, and you can prove this, right? You can look at these two and go, well, can I simplify these? I can't simplify this because this is 1 on top, so you can't make it any smaller. But I can simplify 2 over 4 into 1 over 2, right? Divide both top and bottom by 2. And I can simplify this one by dividing by 4, which would make this one 1 over 2. And so you can see that when I simplify all my fractions, all the fractions turn into the same one. And so you say that these fractions are equivalent. And that's basically what we're going to be doing for these guys, right? That's what we're going to be doing for ratios. I'll show you a little trick with them. You can temporarily turn ratios into fractions just so that you can make it easier to simplify. But once you get used to it, you don't have to do that. Essentially, equivalent ratios are different ratios that show the same relationship. So they're different ratios, they have different numbers, but they represent the same relationship. In other words, these ratios can be simplified into the same one, right? So again, in the previous lesson, we talked about simplifying ratios. It's the same as simplifying fractions. So in fractions, let's say we had 3 over 4, and we have the other fraction of, let's say, 15 over 20, right? Are these fractions equivalent? Are these fractions the same relationship or the same proportions? Well, can I simplify 3 over 4? No, because 3 is a prime number. Can I simplify 15 over 20? Yes, I can. They're both divisible by 5, so I can divide this by 5, which would give me 3. And I can divide this by 5, which would give me 4, right? I can simplify this fraction into this one. And as you can see, they're both the same fraction. So 3 over 4 and 15 over 20 are equivalent fractions. And this can also be said if I had the ratio of 3 to 4 and 15 to 20, right? Once again, I can simplify this ratio to 3 4, right? I can simplify this guy into this guy, and so you can say that 3 to 4 is equivalent to 15 to 20 in the same way as 3 over 4 is equivalent to 15 over 20, right? So again, ratios are very, very, very similar to fractions, and so you can follow the same similar rules that you've used before in previous years to simplify ratios. So to find equivalent ratios, you can turn them into fractions for your calculations, but please, please, please make sure that you convert them back for your answer. Remember, don't if you're going to turn a ratio into a fraction, turn it back into a ratio. Because if the question is dealing with ratios, it's going to ask you for a ratio as an answer. And if the question is dealing with fractions, it'll probably ask you to turn it into or keep it as a fraction. It may ask you to turn it into a decimal or percent, but if the question is in fractions, keep it as fractions. And if the question is in ratios, well, then keep it as a ratio as your answer, right? So have your ratio as your answer if the question has ratios in it. Now, if the question told you turn it into a fraction, then you can do that. And that's the way of being safe so that you don't make these kinds of mistakes. So here we have 45 to 90. If we had, let's say, a total of 90 marbles, and 45 of them was red, then you have a part to whole ratio. 45 red marbles to a 90 total. And again, only part to whole ratios can be shown as a fraction at the end, but part to part ratios need to be turned back into ratios. So here we have a ratio. We can temporarily turn it into a fraction. And if you look at this fraction, you can simplify it, right? 45, 90, well, that's half. So you can say this, 1 over 2, right? Now turn it back into a ratio. The top number is the first one, 1, dot, dot, and 2. Let me just fix that. It's kind of terrible looking right there. I just fixed that dot. There you go. So 1 to 2. And so you can say that these two ratios are the same, just like how these two fractions are the same. And they are equivalent. They represent the same relationship. So, example, you have the ratio 5 to 10 and 45 to 90. Are they equivalent? Right? So, pause the video, see if you can solve it, and then we'll take a look in a minute. All right, so if you pause the video, hopefully you solved it. You can find out both by just looking at this. Well, 5 to 10 is the same as saying 5 over 10, and that's the same as saying 1/2. So the equivalent ratio of 5 to 10 is 1 to 2, because the equivalent fraction of 5 to 10 is 1 to 2, 1 over 2, or 1/2. Right? Here we have 45 to 90, and as we did before, 45 over 90 as a fraction is 1 over 2, so then the ratio is 1 to 2. And so you can say they are equivalent. Yes, they have different numbers, 5, 10, and then 45 and 90. They're different numbers, but their relationship is the same. 5 to 10, the relationship 5 has to 10 is the same as 45 to 90. 5 is half of 10. 45 is half of 90. So you can represent this relationship as 1 to 2. So you can say that these ratios are equivalent. So do these and check to see if these ratios are equivalent. So 48 to 64 and 72 to 96, 9 to 27, 27 to 81, and 25 to 60 and 45 to 120. So you can do those on your own, and we can move on from that one. Again, it's the exact same as something you've done before with fractions, right? 48 to 64, okay, well, simplify that as though you did a fraction. 72 to 96, simplify that as though you did a fraction. And it's the same rules. It's just instead of putting one number on top of the other, you're putting them next to each other with a colon in the middle. So to find ratios that are equivalent, you simplify both of them. If they turn into the same ratio, then you say that they are equivalent. Just like in our first example we showed on the title page, all of these pies are equivalent because they all show the same relationship. If you simplify 2 to 4 and 4 to 8, you would get 1 to 2 for each of these. And so you say that they are equivalent. They represent the same relationship. So you can take a look at this part as well. This is a little bit of extra practice you can do. And you can try and solve these equivalent ratios. All right, try and see which ratios represent the same relationship. And that's it. That's the super short video for equivalent ratios. It's an important one because, again, just like with fractions, I'm going to ask simplify your ratios. Always simplify them. Make those numbers as small as possible. So I gave one whole lesson on simplifying ratios because they're just as important as simplifying fractions. So I'll see you in the next lesson.